Hi folks, we're going to continue on. Hopefully you saw my email. This is the problem that I wanted you to do. So we'll go over this one. Let's start with end behavior. We know that because the leading exponent is even, we know both ends are up or both ends are down. Because the leading coefficient is negative, that means both ends are going to be down. Symmetry, we know we don't have any because we have even and odd exponents. And let's talk about the y-intercept. If I plug in f of 0, that would be 0. And then let's talk about the x-intercepts. So I do have a GCF here of x squared. So if I take out x squared, I end up with x squared. Actually, I'm going to take out a negative x squared. So that would leave me with positive x squared minus x minus 2. And so that would give me x equals 0 over here. But remember, there's two of them, so that has a multiplicity of 2. And then here we end up with x minus 2 and x plus 1. And so our roots are at x equals 2 and x equals negative 1. Okay, so those are our roots. We know what the y-intercept is just at 0. And I know I have roots at negative 1 and at 2. And I know that my ends are up, right? My ends, I'm sorry, the ends of my graph are down, which means that my graph is going to somehow, it's going to come up here, through here, then it's going to come back. And because it has a multiplicity of 2 at 0, it's going to turn, and then it's going to come back down. Okay, the question is, how high up does it go at this point and at this point? I would go to the calculator and see how far it comes up or how far, just how high it is at that point. And you can easily do that just by plugging it into the calculator. So I have negative x to the 4th plus x to the 3rd plus 2x squared. And if I were to go to the calculator, I just have to go to the table, and at x equals 1, I'm up here, let's see, I'm up at 2 when x is equal to 1. So it's pretty close to what that looks like there, roughly. Let's see, at x equals 3, I'm way down at negative 36. So it's roughly about there. If it's not exact, that's okay. You just don't want it to, you don't want to have your graph way up here if it's supposed to be down here or something like that. Okay, so that's how you would go about doing a problem like that. Let's talk about rational functions. Okay, so we have a rational function here. In this one, it's easy to miss, but there is a negative out in front of the function. So just make sure you're aware of that. I would tend to just put it up in the numerator just because I think then it doesn't get lost with anything. But when we are talking about rational functions, we are going to check for symmetry, which we don't have because we have even and odd exponents. And we're going to do similar things that we did with the polynomial functions. We don't worry about end behavior, but let's find our y-intercept. So our y-intercept would just be f of 0. And at if I did f of 0, right, I wouldn't get an answer. It doesn't exist, correct? Because that would just mean I'm plugging in 0 for x, and that would give me a 0 in the denominator. So I don't really have to worry about that. My x-intercept is going to be a little bit different. So let's look at the vertical asymptotes first, because we already know that we have one at 0, but remember when we're finding vertical asymptotes, we set our denominator equal to 0 and solve it. So we have x times x minus 3 is equal to 0. So x is 0 and x is 3. So I have an asymptote here. Actually, let me do that different color. I'll do that orange. I have an asymptote here. And I have one. Oops, I have one right there. Okay, so those are my asymptotes. And this can't be reduced at all, so I don't have any holes or anything in my function. But now we have to go ahead and graph it. So here's where I say to go ahead and plot points beyond and between. Now notice, remember we said horizontal asymptote. Horizontal asymptote, I didn't talk about this yet. I talked about x-intercept. Horizontal is when the degree of your numerator is smaller than the degree of your denominator, which it is in this case. So you have a horizontal asymptote at 0. Okay, if they're the same degree, remember that you just take the coefficients of the top and the bottom. If the numerator has a higher degree than the denominator, there is no horizontal asymptote unless it's only 1 degree higher, then you have a slant. Okay, so that's the different issues or the different circumstances you have with horizontal. So I know then that I have an asymptote here as well. And then from here, you're just going to plot points beyond and between your asymptotes to get an idea of the shape of the graph and what it looks like. So here's where I would go ahead and put it into my calculator. Make sure you use parentheses. Minus 3x, parentheses. Okay. And I would go to my graph, or excuse me, go to my table, and I would start plotting some points. So it looks like as you get closer and closer, so at -3, you're at -0.2, so you're here, and then you're at -0.4, and then you're at -1. So you get the idea that this graph is kind of coming around like this. Oh, wait a second. Backtrack. Sorry, those are negative. So actually, I'm in the wrong spot here. These would be, getting ahead of myself here. These would be down here, right? So these would be, you'd have more something going like this. And here. And then let's look between 0 and 3. It looks like we just know when x is 1, this is 2. And when x is at 2, this is at 2. And then when we scroll down and we go beyond 3, it looks like we're negative again. So we've got this going on again. So what's going on here? These two, we have values at 2 and 2. Our graph is not going to go straight across because it doesn't. It's more of a curve. So you can tell by that then that you're just going to kind of come down and back up. And that is the general shape of your graph. Okay, in the next problem, we have a little bit more work to do because we need to reduce our original problem. So when we reduce this, we can factor the numerator and the denominator. So if I factor the numerator, I end up with x times x squared minus 9, which gives me, let me write it over here, that gives me x times x plus 3 times x minus 3 in my numerator. And my denominator, when I factor out a 3, I end up with x squared minus 2x minus 3. So that becomes x minus 3 and x plus 1. Okay. Now I can cancel out my x minus 3's, and so I'm left with x times x plus 3 over 3 times x plus 1. Okay, so that's what I'm left with. I use my reduced or my reduced form or my simplified form when I'm graphing. So symmetry, clearly we don't have any. Let's talk about intercepts. So if I were to multiply that out, I end up with x squared plus 3x over 3x plus 3. And if I plug 0 in for x, I end up with 0 for the whole thing. So my y-intercept, so f of 0, my y-intercept is 0. So I know I have a y-intercept at 0. Let's talk about our vertical asymptotes. Now, in our original function, we would have had 2. We would have had it at negative, or at 3 and negative 1. But because we canceled those out, we now have a whole at 3 because of the fact that in the original function it would have been undefined. Okay, so we will have a whole at 3, but we do have a vertical asymptote at negative 1. So let me go ahead and graph that. And then just remember a whole, we'll have a whole at x equals 3. Okay, let's talk about horizontal asymptote. Now we're going to again go to our reduced function. Because our degree of our numerator is 1 more than the degree of our denominator, or because it's more than our denominator, that means we will not have a horizontal, but because it's 1 degree more, we will have a slant. Okay, now because there's a leading coefficient here, we cannot use the synthetic division. We do have to do long division for this one. And it's really not that hard because it's really short, right? All I'm doing is this 3x plus 3. And what do I have to multiply 3x by to get x squared? Well, I just have to multiply it by 1/3 x. So that would give me x squared plus x. And then when I subtract, I end up with 2x. And you can bring a 0 down if you want to. And then what do I have to multiply 3x by to get 2x? Well, I have to multiply it by 2/3. Okay, and then that would give me 2x plus 2 here. And that last part I don't care about. This part is the equation of my line. That's my slant. So I'm at 2/3, so I'm roughly here. And I have a slope of 1/3, so I go up 1 and over 3, 1, 2, 3, up 1 and over 3, and you get an idea of where your slant asymptote is then. Okay, and then from there you can go ahead and graph. You can get points from the calculator, and just in the interest of time, I'll just graph this out. We go through that point, and we end up, actually go through the origin there, we end up there. And we end up over there. Okay, so that's basically a general idea of how that would look. Okay, and the last one is very similar, and I'm out of time, but you're going to go about doing that the same way. You reduce it if you can. You will have a horizontal asymptote at y equals 3, and that'll help you with that one as well. Okay, thanks everybody. Take care. Bye-bye.